knowledge and skills in terms of addressing societal challenges. So it's one of the thematic areas we have at the OED. And again, when you tell people about this, they tend to not be able to conceptualize what you mean by astronomy knowledge and skills. Like they know they have the skills, but then they can't imagine how they can possibly apply them in things outside of data science and just the research. So hopefully Cormac will tell us a bit more about his work and how he uses his astronomy skills and knowledge to apply it to things outside of astronomy. And also we will learn new techniques on we'll learn new techniques that can be applied in development challenges as well. So yeah, thank you so much for being able to join us today, Cormac. Do you want to follow Martin or when he introduces himself?
So I will say a bit about Cormac, but I think first we can just let Kevin just tell us quickly what the spirit of the full moon mashup, is actually all about.
Well, thanks to Charles and Joyful for putting this together, and thanks Cormac for giving us the time. I think the spirit within the Office of Astronomy for Development, within these mashups, is really it's a safe space for us to talk about one main objective, is how to use astronomy to make the world a better place. And whether we're using astronomy to impact on technology, whether we're using astronomy to impact on other fields, techniques, whether we're using it to inspire people, to bring economic development through tourism, it's all open. And these mashups are really a space to find really cool people like Cormac who are doing interesting things with astronomy knowledge, and just have an open brainstorm and see what comes out of it, what new ideas we can get that the OED can maybe follow and take forward. So thanks very much, everyone. Thanks to all the participants for joining.
Yeah. Thank you so much, Kevin. So just a bit about our guest today. Cormac Purcell is an astrophysicist who has now turned into a scientific entrepreneur and an intelligence system engineer. He has led various projects that look at how we can use space-based data, AI, and sensor network to help people make better decisions here on Earth, looking at things like bushfires, mapping floods, and monitoring shark activities. So how this full moon mashup is gonna go is that Cormac is gonna now go ahead and start, just giving us a presentation about the work that he does, and then thereafter, we'll then open up for some questions, and then we can all then listen to some ideas that some people that are joining for this full moon mashup, as Kevin mentioned, that we are here to sort of see how we can all come together and sort of build and develop ideas, into something, and hopefully, our idea is to see some of these ideas that come through this full moon mashup result in a proposal maybe a year from now when our call for proposal is open. Looking at a way that we can use astronomy techniques to impact positively on society. So without taking further time, Cormac, you can go ahead and kick us off. Thanks.
Thanks very much, Charles, Joyful, and Kevin. It's a real pleasure to be here. So I really appreciate the opportunity to talk and discuss with everybody who's dialing in as well. I should say that if people want to reach out to me with questions, they can do so afterwards also. Let me share my screen and hopefully you can see my presentation. I'm not going to take too long on this because I want to hear all of your voices, really. Okay, so can you see my screen?
Yes, we can.
Yes. Oh, okay, excellent. Okay, so really I'm going to talk about a little bit drawing on my journey as an astrophysicist. I have had an interesting career, not particularly well planned, but certainly sort of has led to very interesting opportunities along the way. I did a degree in applied physics and then a number of postdocs in the astrophysics world. Became a lecturer at a university in Australia, and then over the last 5 or 6 years, I've moved into the tech world with one foot in academia also. And I've worked on a whole variety of different projects. When I was in the thick of doing my astrophysics research, I was using instruments like the Very Large Array in order to survey the galactic plane for young star forming regions, and zooming in on some of these to investigate them in much more detail. I'll just give a quick brief overview of those. I moved on and I sort of went sideways a little bit and applied some astronomy techniques and machine learning to an ecology problem around tracking and monitoring and identifying sharks. And then became more of a conference organizer for a while before moving into telescopes looking down and looking at how we could better manage bushfires using data, running and helping lead a international science programs called the Frontier Development Lab with a company called Trillium Tech, which also put me in the firing line for doing some programming on board satellites to release a machine learning app as a demonstrator, all looking at floods. And now I work in the tech industry looking at logistics and transport to solve societal problems. So just a little bit of a reflection of the sort of astronomy skills and techniques, including the soft skills that I've found quite useful and have really backed up what I can do over the last while. I kind of want to divide this into two columns. I think, when people think of astrophysics and the science that they actually do, they think, okay, how do I apply this in the real world? And the first thing that comes to mind is data science and machine learning and AI. And this is certainly something that is, in the core skill set of anybody in the hard sciences of physics and astrophysics. But almost equally important have been all of the soft skills. And you learn these almost by accident along the way in your training and work as an astronomer. And organizational and business skills are really important. In fact, it's sometimes in the real world, it's those soft skills that allow you to get projects managed well and really well done. And of course, any scientific endeavor is very creative. So the sort of creativity that we bring to our science and the ideas about how we model processes and imagine what's happening in the universe also give us the skills to be able to think sideways and outside the box on problems in the real world. And this is often referred to as innovation and thought leadership in industry circles. So the first sort of skill set that I think we all have is we can make sense of very complicated data. Images like this of the galactic plane are often referred to in the business world as unstructured data, as opposed to structured data, which is the sort of Excel spreadsheets, tabular columns. But we're very good at analyzing this, figuring out how we can put some metrics and numbers around individual star-forming regions or any objects that you're looking at here that are of interest, and measuring their physical properties. We also know how to work in the spectral dimension and go to multi-wavelength in order to figure out the physical properties. And we understand how to do this at scale. So this is a particular survey called Cornish, which I was involved in early on in my career. And it involved large pipelines and large data set managements, which ran on remote servers, but also a lot of bookkeeping, a lot of databases in order to keep track of a multi-year observation program to survey the galactic plane, to come up with huge data sets that look a little bit like this. And we're very good at managing all of that. And even when we're looking at blank areas of sky where there isn't very much, figuring out what's there. And this is a radio image, and at first glance, if you have low resolution screen, you can't really see very much there, but there are point sources here. And finding these at scale was one of the key things that I first learned when I started my career. Now, this was all, when you're finding point sources like this, it's done using fairly simple techniques. These days, source finding becomes more complex, and it's really leverages a lot of machine learning now. But the real core piece of knowledge which I needed to employ when I was doing this sort of work was a great understanding of the data, all of the noise properties, all of the statistics of the sources, and how to really describe them so that anything we found could be of use to later generations of researchers. And actually, that's probably the core skill to take out of this, because techniques of programming, change and evolve over time, but the statistical knowledge that you bring to your data and you bring to your science is something that will never go out of date. And in fact, it's even more relevant in the age of AI, when AI generates hallucinations or can be subtly wrong. Astronomers also know how to dive deep. So the last project was at scale. And we know how to take a single object, like, for instance, this evolving blown bubble around a very high mass star, and understand its properties and dive deep into modeling how it's evolved and how it's worked. This is, by the way, a wonderful source in the southern hemisphere called the Gum Nebula, which would be 30 degrees across on the sky, so much larger than the full moon if you were able to see it in H alpha with your naked eye. But we didn't, up until the point that we were looking at this, we didn't really know what it was. Was it a wind-blown bubble? Was it a supernova remnant? Was it something else? And so one of the skills I picked up was diving deep and building physical models of this using background point sources in order to probe the magnetic field. And when you get these background point sources, they look like this. And then you can build a geometric model and a model of the physics of the processes that is happening within this bubble or shell to come up with an answer. And the key statistical technique that was used here was Bayesian reasoning. And this is something that I found ever more useful as we sort of tackle some real world problems, understanding your priors, understanding the statistics of the data itself, and understanding how to couch your problem in terms of something that you were able to model has been incredibly useful. And this was really the first step that I took along this line a few years ago. Lastly, not to neglect the soft skills. As an astronomer, you pick these up along the way. You learn how to organize conferences, you learn how to manage proposals, you learn how to build collaborations, and you learn how to manage teams and think and work and act in a group. And that's something that is incredibly useful and has been very useful along my journey in the real world. Okay, so like taking that and sort of defining those as the sort of skills that you pick up in a career in astrophysics, what sort of things have I done with it? Just to mention first that academia sort of sits at a scale that we call the technology readiness level scale. So if you're working in tech, then there's a wonderful scale that NASA has come up with called this technology readiness level. 1 to 5 is really the sort of research that's done in academia, whereas 5 to 9 is when you have a prototype system that evolves into something that you can deploy in the real world. And if you end up or work in government or industry, you'll often be working with mature systems that have been deployed already. If you're working in academia, you'll be working on the cutting edge. And the most difficult place to end up in is in the small or medium enterprises, where you're trying to take an idea which is not particularly proven yet and build it into something that people will use. And this is where you find a lot of the issues around where data actually meets the real world and where systems actually meet the real world. And that's certainly the journey that I went on when I moved out of astrophysics and into the real world. One project that I ended up working in collaboration with a few years ago was looking at flooding. And instead of telescopes looking up, it was telescopes looking down in order to map where the floods had been so that we could give accurate maps to first responders and to recovery experts to help people recover from the flooding. And this is an increasing problem all around the world with climate change. You can see here that this particular town was flooded to a depth of, I think, 14 meters. This is a 2-story building, happens to be a McDonald's that was submerged underwater. You can't see any of it there. One of the things that I ended up doing as part of the project was building a machine learning payload that launched on board a satellite and actually processed in real time very large images in order to send a vector map, just a series of lines, down to the ground about where the water was. And this was a proof of concept that we could do this over very large imagery. And the skills that I ended up using that I had learned in my astronomy career were coding and Linux. So it's this ran on a little Linux machine on board the satellite itself. Knowledge of the data, knowledge of how to do survey mode data, because we did each of these, like the previous survey with the VLA, we did this in a tiled mode. And the same sorts of processes and the same sorts of data analysis all were brought to bear in the same way, as well as some of the computer skills that I had developed over the years. All of this worked really, really well. We were able to transfer this across multiple cameras and take some images from orbit and figure out where the land was, where the cloud was, and where the water was in order to transmit this very fast to the ground. We later built the similar system into a tool that was actually deployed to map large-scale floods that happened on the east coast of Australia during 2022. And this was a map that was used by government in order to figure out where to provide recovery relief for affected communities. The McDonald's that I showed before was sitting right in the middle of this riverine flood here. And so that was really an analogous project to the astronomy projects I had done before, but with just telescopes looking down and technology development in order to support that. And the technology in order to build these maps was done in the cloud with a machine learning pipeline where, if a flood event occurs, the satellite acquires the images. These are available on an archive, just like in the astrophysics world. The data is loaded, and then we use cloud processing and here on Google Cloud in order to run an AI modeling tool that is essentially a source finder on a pixel by pixel basis, and then prepares a flood map for use on the ground. Another project that I ended up working on was around ecology and safety. And this is because in Australia, there are reasonable numbers of shark attacks off beaches, which worry the public. Previously, the authorities there have used helicopters in order to sight sharks and figure out if the shark is a dangerous shark or simply a harmless ray, and then close beaches or warn the public that they shouldn't go swimming. And also to do research on tracking the sharks, because we want to know if their populations are healthy. They are a litmus test, a bellwether species for healthy coasts. And so we want to make sure that we understand the ecology of the coast and the apex predators that are living in the sea. So this was, again, another application of astrophysics tools where we have data looking down. We were using drones with cameras and taking a live video feed and then trying to provide real-time intelligence to the people on the beach who were operating the drones that there were shark in the water, and also help ecologists survey sharks. And again, this is a source finding and image identification problem. We built up large data sets, which we had to know the statistical properties of very, very well. And then we built machine learning object detection models that could run on compute constrained devices in order to say, yes, this is a hammerhead shark, or this is a bull shark, or it's a harmless ray. Hopefully my video will play. So this is the sort of thing that was running on a mobile device on the beaches, and then went to live trials in order to find out if we could do well in identifying the shark species, because some shark species you don't want to worry about, and others you would definitely want to clear the beach. Bull sharks are quite dangerous. Okay, if I can move on. And so the sort of thing that we needed to understand about this was the performance of the models, how well they actually did, and why they actually failed. And again, the data science and analysis tools that backed up that were all learned in the astrophysics world. One thing that I will say about this is that the soft skills are also important. We built a set of partnerships here, which involved the Queensland government and a startup and a number of other agencies who helped us with data. And really, it was the soft skills that were equally important in all of these, not just the astrophysics technical skills. In my career later on, I've also been working with lots and lots more partners, increasingly more, acquiring funding, taking on the proposal skills that we've used before and generating these ideas in order to figure out what we would actually build in the future. Working with researchers across a wide range of places in order to manage research programs and then help them get the best performance and provide mentorship to them also. And building the partnerships, which of course involves negotiating contracts, and then building out communications and reports which help the public and the downstream stakeholders understand the work that we've ended up doing. So here's a good example that when I was working with Trillium, I was the lead of a bushfire situational awareness report, which looked at the ability for technology to help manage bushfires. And this involved understanding and working with firefighters and data providers and really getting to the heart of the problem, understanding the problem before you understood what possible solutions there actually were. And so being able to communicate well in diagrams how information flows is a real skill that you learn in the astrophysics world from making all of your wonderful plots, but then translated to all sorts of end uses at in the real world also. So one final provocation for the discussion. AI, of course, has come along, and especially the chatbots, which are able to do coding now, and they're really changing how all professions that work with technical skills are done. You know, 5 years ago, if I was looking to build an app or looking to build an analysis pipeline for any of the projects that I was shown here, it would take me a couple of months at minimum to write something. Now using ChatGPT or one of the other code assistants, I can get a pipeline like that up and running and working in a few days. But there is a caveat. Without the skills that I had acquired doing this by hand from scratch, I wouldn't know how this has gone wrong, because all of the AI generated code, while it seems good on the surface, often has really subtle errors. And so the real skill that you bring to, that astrophysics brings to the world, when you can, utilize these tools to generate something very, very fast, is that you can dig into the details of this, and you can understand from your statistics and your prior knowledge when something is going wrong. So we're moving from a regime where we're learning to code really, really well, because in some ways the machine can actually do this for you, but you'll need to be able to validate really, really well. You'll need to know when the machine is going wrong or when it can introduce a subtle error. So I think I'll stop there with that and open up for discussion. Oh, I think you're muted.
Okay, there you go. Oh, sorry, we couldn't find our own unmute.
I do that all the time. So
no, that was really great, Cormac. Thank you so much for just taking us through that. I think there's a lot of interesting, things that we can take from there. I don't know. First, I think we just would like to let's open up for some questions from our audience first, so that we can just start interacting with them and comments or anything that might come to mind from anyone in the audience. You can just start there. You can just put your hand up, and then we'll allow you to unmute yourself.
Yeah, Mbonga has a hand
Yeah,
up.
so CCI has got a question. CCI, Mbonga, please.
Good morning. Can you hear me?
Yes, we hear you fine.
All right. Okay, cool. Hello, everyone. I'm Sam Bonga from the University of the Western Cape. Thanks for the interesting talk, Cormac. Sorry. Okay. Someone asked me to start my video. Hello. Sorry, I'm at home. Thanks for the interesting talk. It's one of the things that in my mind, one can use actually your skills in astrophysics, particularly for development. quite interesting. You put up an example about flooding, and where I'm from currently, there's a situation around flooding in the area, and we've seen basically devastating losses of lives, numbers of lives. People are essentially trying to help people around. But essentially, the problem lies with people building, constructing houses below the flood line. And the city itself is built essentially around the dam there. And so, for instance, having this kind of tools prior and having the government involved in doing research around this, those lives could have been prevented today. Well, my interest is in basically particular to that, how well, for instance, we talked about being able to use your soft skills to work with governments. How was it easy? How hard was it for you to essentially communicate with government to see basically the need for, particularly in the issue, the problem that the flooding problem that you had, and how easy was it to get the buy-in from government so that they can see the importance of having such tools and employing them so that they can deal effectively with such situations? Thanks.
That's a really good question and quite insightful. I could probably speak for an hour on the nuances of working with government, and when it works and when it doesn't work, and tips and tricks on having a successful relationship. But I think the best piece of advice coming from hindsight is that you have to develop a good relationship with somebody who can be your advocate within government. There are ways to approach government in more formal processes where you can, there are open calls when the government knows it needs some piece of tech or some advice. There are often open calls in order to be able to formally advise. But the way that we ended up working on flooding was much more organic. We ended up having a conversation at the right time, at the right place, which was great. But then also developing a good relationship with somebody who could advocate on our behalf and who were willing to take a risk in order to say, okay, well, let's sort of do a small project and figure out if this is something that could work. And then it led to a bigger one and led to a bigger one. And it really was baby steps at first, but in proving that we could do something well, it led to a much bigger project in the end. But that would have been the key thing here, was to find an advocate who you can sit down with and who will be willing to listen and understand the problem, and then forming a cluster or a network around that, which gives you support and de-risks the government from actually sort of taking a risk. I guess it's always very interesting to understand it from the point of view of government also. If you're a small organization like a startup or just a small company, they will always see that as taking a risk in order to go to a small company and ask for a service. At the same time, they know that small companies are more innovative and can move faster. And so if you find a problem which requires a solution to be developed in a quick time, and a government partner who's willing to take a risk, then that's a perfect place for a small startup or an organization to sit, as opposed to some big consultancy company who are more likely to, sort of get a different type of project.
No, thank you. Thank you very much.
Okay, I hope that helped answer your question.
No, indeed it does. Thank you.
Yeah.
Is there another question that we have online? Anyone have their hand up? Yeah, in the meantime, I just have, on something just slightly a bit related, is that while speaking to governments is one part of the problem, the other part, of course, is the whole issue around funding as well for such projects. And I saw that you mentioned earlier in your presentation that you've looked at, you've worked on acquiring funding for some of this project, because it sort of requires that those resources. What is sort of advice that you can give to someone that that's got an idea that they want to, to sort of be funded, but don't know what the right people to, that they can speak to about that.
Yeah, I'm not sure I'm the right person to offer too much advice. I'm still along that journey myself, but I think the back when I was working as an astrophysicist faculty, I was applying for telescope time and grants and science ideas. And the metrics for success there were often that you'd done your technical due diligence, the project you wanted to do was possible and feasible on the telescope, or with the instruments that you were using. And it also had to be innovative and would likely produce something of scientific value and often legacy value, not just for yourself, but for the wider community. And you had to demonstrate each of these things. In the real world, often you have to make a business case. So increasingly, the grants or the startup funding or whatever type of funding that you want to acquire, it will require you to be able to say they're going to get a return on investment of some sort. And that return on investment might actually be only that you succeed, but you have to have a business plan where you if it's a commercial product, you're generating revenue after a certain amount of time. You have to have that backed up with actual research on whether people will actually use what you want to use. And even from the technical point of view, often people have an idea because they think they know a problem and say, "Oh, great, I can solve flooding by building an app that connects people and tells people what the water level will be," for instance. But when it comes to actual deployment, it might be something subtly different that is needed. In fact, they don't need to know the water level. They need to know whether their rescue routes are available or whether they're going to get cut off in advance. And so when you're applying for funding for an idea, you have to understand the idea from the customer's point of view first, from who's going to use the thing that you're going to build. And one good example, like the bushfire report, which I showed earlier, was an attempt to do that. Rather than coming in from on high and saying, "Oh, I think I know how to solve your problem," we sat down first and said, "What are the problems that you find?" And in that instance, for instance, the major problem wasn't the lack of intelligence on the ground. They knew where the fires was. The major problem was around communications within the fireground. Often in the Australian context, firefighters would go out and they would be in remote locations and they couldn't communicate properly with the people ahead of them or behind them or at the incident management team. And so the problem wasn't, the generation of fire maps. The problem was communications. And it's really the sort of showing that you understand the problem to be solved rather than just showing that you have an idea. And you have to have evidence for that in terms of interviews and research done. And then funding agencies will look much more favorably on you if you can prove that you're solving a real problem and the solution that you're offering will actually solve that.
Well, thanks, Cormac. I think we do have another hand from Philomena online. Philomena, you can just unmute yourself. If you want to put your video on, you're welcome to do so.
Yeah, good morning, everyone. Thank you so much. Very happy to be here. I just want to first, really great presentation, and it took me back to 10 years ago when I started my career transitioning from software into astroinformatics then, and that was really made possible by the OAD through the JEDI program. So a very hearty thank you to Kevin and the entire team, and similar to yours as well. Yeah, we have to give credit where it's due. And similar to that, I also applied it to global challenges such as wildlife conservation, especially in communal conservancies around rhino poaching and providing real-time precision agricultural data to indigenous groups in Kenya and Namibia. But also talking about the critical infrastructure, which is cyber physical infrastructure, and the role certain sectors and industries can play in accelerating innovation. So the one question I had, just adding on to the one that the OAD had, was what collaboration for critical infrastructure would look like for innovating global challenges. But also to talk on to the data part, there's a data rush for global South data, be it language, be it imagery, mapping, health, which really mirror extractive industries. What are some, if any, lessons can we draw from astronomy around data sovereignty that we can use to drive local innovation in industry? I remember from my time at I think it's the DARA project, you needed to apply for, observation time, and you had some sovereignty over the data for a period of years before you could make it accessible. We don't see this happening, translating into NLP, for example, or within computer vision, where locals have sovereignty to their data. In fact, Africa does not own any of its data at the moment, according to a report. So what are some of the lessons we can learn with regards to sovereignty to drive local innovation that really translates to local economies and global self-development?
Yeah, I think you raise a really interesting question, and again, it's a kind of worms. Most of my experience in the astrophysics world has been around open data sets, or data sets that are acquired with the promise that they will be made open within a year. So they only have a very short period where they're private for the researchers themselves. I've been lucky enough when moving into industry that I've been working mostly on open data sets, at least within the European Union. So a lot of the flooding work, actually that flooding tool that I showed is an open source tool that was developed for as part of the European Space Agency grant. And most of the European Space Agency grants, they mandate that the tools that you build will be open for the community to build on. It also uses the Copernicus data sets, so the Sentinel data sets, which are, I think, freely available online, at least to Europe. I'm not sure about Africa. But to answer your larger question, it's critically important to have high quality open data sets that are in fact owned by the people who are going to be making use of them. And unfortunately, we are seeing a move down to a more locked down commercial world, I think, especially in the satellite industry. And this is largely because most of the satellites being launched now are done under commercial banners. And so you really, the key programs that allow you to use and acquire data sets are the ones being run by national space agencies. And when so the Sentinel program in particular is incredibly useful because it makes a map of the Earth every 5 or 6 days. And most of that archive is freely available online. But there's a second bottleneck, which is around understanding and processing the data itself. And I think Africa has a real challenge in acquiring and building out the processing power and telecommunications networks in order to have native data centers which are sustainably built and sustainably managed and run to provide access to that data. Now, I don't know the national context. I have a little bit of experience with the DARA program, and I know they're building a few clusters called Iron Hive. And these are something that will be useful for the community, but there needs to be a nationally managed plan. But I don't know, maybe you could let us know if there is something that is more national based on individual countries or Africa wide. Maybe the AU OAD could comment.
Yeah, I think we've got a lot of fields that deal with data that are looking at this, and the one that we've engaged with once is called Data First, and that's under the economics department within the University of Cape Town. But that model is, where they sort of gather development data, make it freely available to researchers. Is a way where the university actually deals with the sort of openness of the data and the permission and things like that, and makes it available for researchers to play with the data to try and come up with new techniques. That's the only sort of like really cool development data model that I've seen. But I know that different fields, whether it comes to language data or satellite data and stuff like that, each of the fields have their own sort of systems in place. So something that unifies everyone would be great, especially policy-wise. But I haven't seen it yet.
Yeah. I mean, I think if you look at the bigger picture, a lot of this mandated data sharing and data acquisition needs to be driven at the government level, because you need to be that big in order to drive it. It's very difficult for individual institutions, whether it be universities or research departments or even large companies who might have an open source or open data policy for some of their work. It's expensive because you need hosting, and and you need to provide some support or at least some level of quality control around it. As you start getting into data sets which have real world impact, you need to put in place guards so that it's not abused, or at least guidance so that a data set is not used or where you could draw the wrong conclusions for it. So for instance, the space agencies, while they support the launch and acquisition of Earth observation data for general dissemination, their remit on the data stops when it comes to just delivering some level of calibrated data cube. They do not host products or systems which allow you to make flood maps or allow you to conclude where a bushfire is. It's left to other organizations to do that. And that at the moment is where the gap is. And the reason that these national organizations don't host the inference products or the intelligence products is that they're afraid, I think, of a certain amount of liability associated with them. So if they provide a bushfire map, it has to be under the disclaimer that this is a prototype product, or this is a product which can't be used to save lives. It's only for suggestion only. And it's left up to private industry to sort of try and make something that is a little bit more, I guess, risky. Whereas the government is a large target. If someone's house burns down and they say, well, you told me the fire front was too far away and the predictive model said that it wasn't going to be here, the government could see themselves as being on the hook for lawsuits. And so I think it's a tricky area.
So, and I think also just to add on to the conversation discussion, Wilhelmina also added that the CHPC and NICIS centers through SADC were addressing their cyber infrastructure problem. So,
CHPC is Center for High Performance Computing.
It's like an international thing.
It's South African. I'm the CSIR.
Yes, so there was a question from Ligeta. Well, two questions actually. So the first one, the first comment is thank you for the nice presentation. And then he's asking, how can phenological variations and the effects of climate change on ecosystems be studied using astronomical time series observational techniques? So this is all Greek to me, Charles. This is all Greek to me, but and then it's like, okay, we'll do
I don't feel qualified to answer that question. Yeah, I think that's a whole research project in itself. Certainly there are plenty of techniques from astrophysics which would lend themselves to it. I'm not a pulsar scientist, but I know that the pulsar community have some very sophisticated time series analysis algorithms, and there are plenty of other uh, interesting pipelines for data processing coming out of the transient radio astronomy community as well, which is really they've gained a lot of good results in the last few years, looking at things like fast radio bursts. But I'm sufficiently far away from that sort of time series analysis that I can't really comment. I am at the moment working on a project I can't say too much about, but in the transport sector where we're looking at time series of movements. And a lot of the basic techniques that we would apply to spectral line processing or statistical processing all apply there as well, like looking at the properties of the noise along the data stream, looking at sort of principal component analysis or other types of statistical pattern matching, which can tell you about features in the data set. But I think often there is, and this is kind of one of my general points as well, often there is a focus on the algorithm, and there are plenty of good algorithms to apply to any particular problem that you want. But I would advocate for a focus on the data first. You need to get a really high quality data set and understand the properties and the biases of the data sets before you do anything. And I think if there's one message that I would say, you know, in my career, the data has been much more important than the individual algorithm that I have applied or my colleagues have applied. Building good data sets is hard. It's often time consuming and you really need to understand it, but it reaps lots of dividends. So for the study that you're suggesting, I would understand the data first.
Yeah, and then the second question is how can let's go. Great. Okay, how might local populations' capability to carry out long-term ecological monitoring be improved by capacity building in astronomical data techniques?
Okay, so it depends. I think there's so when you say capacity building, I think it's looking at a greater quorum of people who have the skill set. I can only really point to the DARA project, which I've been involved in for the past year, to say that I think there's, having met some of the cohort earlier in the year who have done incredibly well on their training. Having chatted to them, I can see that there are already many different ideas to which they will put the same skill sets that they're learning to. And maybe the answer to that is more projects like DARA, maybe done within Africa with African leaders. But that sort of general data training where you get an appreciation for the skills that you need is cross-transferable everywhere. And if we could scale more of these types of training projects to give more people an appreciation of the data sets, the statistical techniques, and the skills, with the intent to transfer them across to different domains, that would be great.
I think we are sort of starting to get closer to the 1 hour mark. And I was just thinking, earlier Sia mentioned, the current flood situation in the Eastern Cape, in South Africa, for example. I was thinking, obviously, from all of these things, we can tell that there are challenges, that communities are facing. But just from the top of your head, and anyone that's in the room, what is if you could design an astronomy for development challenge today, based on what we've been talking about, what could that look like? And what do you think are the challenges that society face that astronomy can already is well positioned to sort of try to address?
I have an answer to this, but I will wait for the room to have a think first.
Now it's an open brainstorming
Yeah.
session.
So if I can, just from the talk around Earth observation, one thing that comes to mind is I know the issue we've always had in working with communities is it would be great if there's a way to use the Earth observation for the more informal settlements to map out actual access points and routes that ambulances and services can use to get to specific areas, because that's always an issue, the access, and it changes constantly. So a certain access point might be viable today, but not tomorrow. So that is an area where I think it could be well adapted to actually allow emergency services to get into various areas.
Was the volume okay?
Could everyone hear what Dominic said?
Or not.
Oh. Can someone confirm online if they heard, if they heard that? Oh, that thumbs up, yeah. Yeah.
But I also just think that astronomers, astrophysicists, all of this research, so they should also, also focus some of their efforts into dealing with other. I mean, I know there's a lot of data coming in from astronomy, but I don't know, maybe 10% of your time should just be work that you do that is outside of astronomy. That way, we sort of kind of have a pool of professional astronomers and astrophysicists who enjoy the astronomy research, but then they can also contribute to something else that is outside of that research. And then it could also encourage the younger people who maybe don't want to stay in astronomy research to sort of kind of see what other avenues they can sort of slot into to apply their skills. Because I think one of the reasons why people don't know what what their work can be implemented in is because they're just not exposed to those things. And that's sort of kind of a gap that should probably be bridged so people can be aware of the fact that these skills can be applied in beyond machine learning and data science as well.
And I think, one really good example, is the shark identification, thing that Cormac showed earlier. Sort of things that, astronomy, as you mentioned, we use it to identify sources, right? And I'm sure that there are many things out there, that result in some sort of challenge in society people want to could sort of easily identify, even in solving security challenges as well, which are a problem, in many communities in South Africa. That's also a place that people can sort of start thinking and looking, how could we address, those sort of challenges. And I think while we sort of still on this, sort of thinking, as well, is that looking at what our, part of our mandate is as the Office for Astronomy for Development, we're trying to find ways that we can use astronomy, to actually address, developmental challenges. And I think that there is no better place to start looking than with actual tangible astronomy skills that we are using, to sort of see how, our contribution, can be in society. And I think I've spoken earlier about, that annual call for proposal. And I heard, there are some ideas like what Sia mentioned earlier. How can we sort of bring all of those things, into the annual call for proposal, sort of use, the sort of the ecosystem of organizations like the OED, to sort of see how, as astronomers, we can put those skills, to some real good use out there.
We don't have to wait for the annual call for proposals.
Yeah.
We should be having these discussions now. I mean, the annual call happens once a year and it happens to all of the other months. So maybe we should start talking about it now, and it could potentially be something where we really need to wait for someone to submit a project through that annual call, but then just, develop a project now and then start working on it and then see how it evolves. And
and with that, I think we'll just open up one more time. Comment, if you got a comment, you can
hopefully.
I just think part like it's interesting that I've given a talk or two to forums like this where astronomers are asking the question what else they could use their skills for, and if astronomers don't know what else they could use their skills for, then imagine how the average man or woman on the street wonders what astronomers are for as well. So I think there is a lot of work to be done in educating businesses and people who, in the government about the broad range of skills that astronomers can bring to any problem. Like in my journey through the real world, outside of academia, I have found physicists and astrophysicists embedded in all kinds of organizations. And usually the organization either knows that astronomers can do a really good job because they've got particular problem solving skills, or they've just happened upon that person and gone, oh wow, astronomers can do everything. But it's something that's not generally known in the world, that an astronomer can, bring this broad range of skill sets. So perhaps a an outreach or education program that helps businesses and governments and other organizations understand what we do and what we can do, and how, how much of a broad skill set that astrophysics has, would be something that could really reap dividends.
Yeah. If anyone has any idea how the OED can help with that as well, we are sort of also welcome to hearing any suggestions to how we can contribute to that. Kevin?
Yeah.
You're wrapping it up for us.
Yes.
Well, I must say, this has been a great discussion, but I don't know if our participants are shy or something. But I think we should be thinking all the time and asking ourselves all the time, what are the challenges in the world? And as we come across things like the example that Dominic mentioned now, of getting emergency services into informal settlements and things like that. As we see challenges in the world, I think we need to have a culture of asking ourselves, what can we do? We as astronomers, scientists, researchers, but also NGOs, communities. I think if we get that spirit, then we can have sessions like this, which are working sessions, where we can come with a list of problems. I mean, Cormac presented some really cool solutions that they've worked on and so on. But surely we have lots of problems that we can apply ourselves to. And I think if we create this space, I mean, this is what the OED is meant to be as well, is to be a space where we can identify these challenges and then figure out a way. Because like you said, Cormac, I've also heard lots of astronomers say, what can I do? What can I apply my skills to? It's almost like we need a bank of problems waiting so that anyone who comes, here's a data set, here's the challenge, apply yourself and let's see what we can do. Because a lot of these the solutions will grow organically, the partnerships can grow organically, based on individual relationships. But I think there's a space then, like you said, Cormac, with these training workshops, like the data training workshops and so on. If we scale up these things, if we train more people on data skills, then they will also see problems in their communities. But I think we have to recognize that we can solve problems, and Cormac has presented a nice example of an astronomer solving problems in the real world. We know it can be that.
Yeah, I think it would be really interesting to conduct one or two of these sessions with representatives from the real world organizations that have the problem. Like, bring them into the room and have them present. I think one of the most interesting meetings that and workshops that we ever ran in the last few years was that workshop which produced the bushfire report. And we just sat down and listened to frontline firefighters, and after a day of speaking, we understood what their problems were. And it completely changed how we approached the problem. We went in with one set of assumptions going, I think my skills might be useful to help you in this way. And we came out with a completely different, much more validated set of action points where we could actually help. And so rather than have someone like me come in, which is great. I mean, I've had good experience. It would be really interesting to hear from a flood man, a firefighter or a flood manager or somebody who manages a farm, and look at the problems that they have. So be problem driven rather than be solution driven.
Absolutely. I think you're absolutely right, and I completely agree. So watch this space, our future mashups, Turtle.
Okay, noted. Charles is making notes.
Yeah.
That's my note taker.
Right, careful.
Yeah, I know. Wow, it's 12 o'clock. So I guess thank you everyone for joining us today. If any of those discussions sparked ideas that you would like to sort of kind of look into and need people to brainstorm with, our doors and emails are open to everyone. So you can like drop us an email, you can visit us at our office, we can have a discussion on Zoom in person. We're happy to have keep the conversation going. And yeah, thank you so much for joining us today. Thank you for your time, Cormac, and for the insightful presentation and also just this wonderful discussion. And we look forward to having everyone join us at the next Full Moon Mashup. We still don't know what we'll be discussing then, but if someone can come up with a nice suggestion and topic for the next one, we'd be happy to sort of kind of explore how we can have it. So thank you so much, everyone, and have a lovely Friday afternoon, evening, morning.
Thank you, everyone.
Thank you,
everyone.
thank you.
Thanks for hosting me.
Thank you, Cormac.
Thank you.
Cheers.
Thank
Bye-bye.
you, everyone. Okay, bye. Bye bye.